So, so guys, let us consider another example, son. Let us consider another example. So, design of angle strut using double angles. So, let us consider another example. Design of angle strut using double angle for angle to carry a load 400 kilonewton. Use welded connections. Take length of the member is taken as 2 meters. Length of the member is taken as 2 meters. Guys, please remember. So, in previous problem we did with the design of single angle strut. Here it is what double angle, so it is a double angle. So guys, please, as soon as we see the problem, you can see the load is given is working load. So what is the working load is there, it should be taken converted into a factored loads. Please remember, for designs whatever the load is given, it should be converted into a factor load. So to convert a factor load, whatever the load is given, working load is given, it should be multiplied with the 1.5 times. So it comes to be 600 kilonewtons. So as usual, your first step is to what? In design of compression member, your first step is to assume the value of design compression stress value, means FCD value we need to assume. So we need to you need to assume the what is the design compression stress value. Then I got FCD equals to 120 Newton per millimeter squares. Then you need to calculate what is the area required. So what is the area required? So next time, section area required, we need to calculate. How to calculate section area required? So section area required is calculated by taking, so you already know that I explained in the previous problems from page number 34. So from page number 34, we need to take from phase number 34, what is that value of PD is given. PD equals to A into equals to FCD. So I need to calculate what is A. So A is what? PD by FCD. PD by FCD. What is PD here? We can take at present, we can take PD value as factored load divided by the FCD, assumed value of FCD, you will get the what is the area required. So now let us calculate what is the area required. So based on this, calculate what is the area required. I got how much it is. Section area required should be 5000 millimeter squares. Then from steel table, select the suitable sections. So now let us say I selected the suitable sections. How much it is? 2 ISA 200 by 100 by 10 mm. For required area, I selected the suitable sections. So from steel table, similar way I took other values from the steel table. I selected other values from the steel table. What is that? RXX, that is 6.46 centimeters. RYY 3.68 centimeters, means the radius of gyrations. It will be there in steel table, guys. Please, you can go through the steel table for the respective sections. The value of RXS, RY will be given. Similarly, I taken some values like CXX and EXX. CXX and EXX. That will explain you later why I have taken these values. Okay, guys. Now, by using this RXS and RYY, which one is the minimum value I need to consider? Then R minimum equals to 36.8 mm. Now your next step is to calculate what is the effective length. So for effective length, for already said you, for the connections, what is the for connections we providing are bolted connections, all those things. For connections, effective length will be taken as what? So this in this example or problems, I am taking as we need to provide what? Welded connections. For welded connections, effective length is taken as what? 0.7 into L. So 0.7 into L. I explained earlier. So how to take the effective length. So here I given what is that? For angle with the welding. For angle with the welding, effective length will be what? 0.70 into L. In the previous problems, the angle with the more bolts we taken, their effective length taken as 0.85 into L. In this problems, we have to provide welded connections. So then effective length will be 0.8 into L. So how I calculated what is the effective length. Then calculate what is the lambda, means slenderness ratios. How to calculate slenderness ratio? Effective length by R minimum. So effective length will be 1400, R minimum will be 36.8 mm. So lambda will be, I got the value, lambda value is 38.04. 38.04. Now from the we need to for built up section. So it is a built up section, guys. Please, how it is built up section means. So guys, please, is a double angle. So it is a double angle. So is a double angle is a gusset plate. Let us say this is a gusset plate. For one angle is connected here. One angle is connected here. One angle is connected here. So sorry. So yes please, sorry, yes please, here one angle is connected like this, sorry, I will write again. So it is a gusset plate, so it is a gusset plate here. So here one angle is connected like this, one angle is a double angle, so it's a double angle here. So another angle will be taken like this, another angle will be taken like this. So this is a gusset plate, this is a gusset plate. So one angle is connected like this, another angle is connected like this. So it's a built up sections, I can say it's a built up sections. So is a built up section, this is a gusset plate and this is the angle, two angles are connected like this to the gusset plate. So this is a built up sections, is a built up section. So for the built up sections, if you go to table number 10, the buckling class will be what? If you refer table number 10, buckling class will be C, is the buckling class comes to be C. From table number 10 you need to refer table number 10, the buckling class has to be C. Then for the for the lambda values and for effective stress, so for yield stress Fy equals to 250, for lambda 38.04, for 38.04, and for buckling class C we need to go for the table number 9C. Table number 9C, this is given for what? Design compressive stress for for buckling class C, they given the values of FCD for buckling class C. Then for by using lambda and Fy taken as 250 Newton per millimeter squares. Then by using interpolation, guys, please calculate what is the value of FCD. What is the value of FCD? Please remember, after calculating lambda, so it is a double angle section, so I taken as a built up sections. For built up sections from table number 10 you can refer what is that buckling class. Buckling class will be in the C. Then from table number 9C it is given for buckling class C, value of compressive stress, design compressive stress for buckling class C. Then by using the lambda and yield stress Fy 250 Newton per millimeter squares, calculate what is the value of FCD. That's it. So this is how we need to do it. Then by using that the table 9C, I got the value of FCD equals to 200.55 Newton per millimeter squares, guys. This is how we need to find out FCD, guys, please. So table values are given in the tables, you can refer by taking the value of lambda and by taking the values of lambda and effective stress, what is that, yield stress Fy equals to 250 Newton per millimeter squares, find out the what is the value of FCD from using table number 9C. Then your next step is to calculate what is the compressive strength. What is the compressive strength? From page number 34, what is the compressive strength? Compressive strength equals to PD equals to A into FCD. Then I calculated compressive strength is what? 1164.34 kilonewton. It is greater than 600 kilonewtons, so hence it is oversafe. I can say. So hence it is safe or oversafe. So because you can check here, the value is 1164.3 kilonewton. It is greater than the double, nearly double the factored load. So hence it is safe. So this is how we need to do it, guys. Plus then as usual, your next step is to connection. So here in the problem clearly mentioned we need to give the welded connections. Then so let us I draw the angle sections. This is a gusset plate angle sections. What is the depth of angle section? Is 200 mm. So it's a 200 mm. Sorry, guys, please. Yeah, depth of the what is this angle is how much? 200 mm. Connecting length is 200 mm, and this is what is the load is acting, guys, please. What is the load is acting? Factor load that is taken as 600 kilonewton is for both angles, is a double angle. For single angle, what will be the load? It will be taken as 600 divided by 2, it's a 300 kilonewton. Please remember what F has to take as what? 600 divided by 2, because this is for single angle. What is the I'm using welded connections, I need to calculate for single angle, then you can give it for double angles. Then whatever the load acting should be taken by 2. Why? Because it is single angles. So first you need to calculate for single angles, then F is taken as 600 divided by 2. Let us take the length of the weld. In this section is taken as L2 and this will be taken as L1. So L1 and the depth will be 200 mm. So Cxx value, I already said you, it is the depth of the centroid actions where the force is acting, where we have to check. This is taken from the steel book. So I already taken here, you can check here. From the steel book, I consider the value of Cxx and Exx values. So here please remember, whatever the angle is there, so from here to here, it will be taken as Cxx, and here to here is taken as Exx. Here to here is taken as Exx. So this value is 130.4 mm. So given remaining Cxx will be 69.6 mm. Cxx means the distance from the what is that distance from the bottom of the connecting leg to the here in this second, but yeah, I can say bottom or top of the connecting leg to the force where it is acting. So it is centroid distances Cxx at the centroid where the force is acting. So it is taken from the codes. Okay guys, it's taken from the steel book. So Cxx and this is a value of EVA by. This is 200 mm given. So this one. Then size of the weld. Then what is the size of the weld, guys? Please. Next we need to calculate what is the length of the weld required. I need to calculate what is the L1 and L2. Before that, I need to assume taken the value of S. S equals to 3/4 of angle thickness. So angle thickness is 10 mm. So S is to be 7.5 mm is the maximum I can provide. So let us take S equals to, I can provide 7 mm. So let us take this is the maximum. So let us take we need to provide. So let us take 5 mm less. So let us take S value is 7 mm. Then you know that how to calculate the total length of the weld required. So by using force equals to strength of the weld, by using these conditions you can easily calculate what is the length of the weld required. So what is the force? Force is the factor load. Please remember, we need to don't take 600, we need to take in for the single angle. It will be 600 divided by 2, it is 300 kilonewtons. So that force equals to what is strength of the weld? Strength of the weld equals to 0.7 into T. T is what? So T will taken as 0.7 into S. So S is what? 7 mm. S is 7 mm into L into Fu by square root 3 gamma ml. It is 1.25. So let us calculate what is the total length of the weld required. So this so guys, please already know that how to do the connections, how to calculate the length of the welding connections. Please remember how we have to calculate force into strength of the weld. Force into strength of the weld. What is the strength of the weld? Taken as 0.7 into S into L into Fu by square root 3 into gamma ml. Gamma ml is taken as 1.5. Fu is taken as 4 ultimate strength of the plate, and this is what? Force. What is the force? Is the factor load. Factor load for single angle. So that's how we calculate total length. But I need to calculate how much I need to provide the length here and here. So total length I calculated, but I need to calculate what is the L1 and L2. For that, what you have to take? For that, I need to take I taken one section here on one sections. I taken section 1 1, or you can take here also. You can take anywhere. For my reference, I taken the section 1 and here. Then take the movement at this point. So what is the here you can see taking the movement at 1 1. So you need to take movement at that point. Then taking the movement at 1 1. So let us take the movement at that point. So in these figures we can say I am taking the movement at 1 1. What is that? Force into what is that? Weld strength. Welding force into perpendicular distance, and this force into perpendicular distance we need to do it. Force into perpendicular distance, and the strength of the weld into perpendicular distance, this force into perpendicular distance. The same thing we did it here. We can check force factor load into perpendicular distance. What is the perpendicular distance? So you can check here, factor load into perpendicular distance is how much at the section 1 1? 69.6. Similarly, what is that? This force for what is that? Strength of the weld into perpendicular distance. So same thing we did it here. We can check strength of the weld into perpendicular distance. Perpendicular distance is 200 mm. We can check strength of the weld into perpendicular distance. So here I got force equating into the strength of the weld. So equated and calculated what is the length of the L1. So by I calculated what is the length of L1. Then by subtracting into total length, is I got how much I got 323.30. So please subtract the value of L1. I got length of the weld L2 as 210.78 mm. This is how we need to calculate what is the length of the weld required. Guys, please. Steps are similar to the previous problem what we did. So here also we need to follow the same steps what we did earlier. Please remember, did earlier. So thank you guys.